So let's do an example. Let x be the random variable representing the lifetime of a battery. Assume the lifetime of the battery is normally distributed and has a mean of 400 hours and a population standard deviation of 40 hours. Find the probability that the average lifetime of a pack of 4 batteries is greater than 440 hours. So this question is a little bit different to what we're used to because it's asking us about the average lifetime of a pack of 4 batteries. So it's not looking at individual batteries. It's not asking us about individual batteries. It's asking us about the average lifetime of a 4-pack. But the data it gives us up here, let x be the random variable representing the lifetime of a battery, of a single battery. So let's see how this pans out. What they're saying to us right here is, look, this is the lifetime of a single battery. Let's call that x. They're telling us it's normally distributed with a mean of 400 hours and a standard deviation of 40 hours. Now they're asking us to find the probability of the average lifetime of a 4-pack being greater than 440 hours. But this is not the average distribution of averages or the sampling distribution. This is looking at single batteries. That's not what they're asking us about. They want us to take samples of size 4 and set up the distribution when you're dealing with samples of size 4. The distribution of averages when you're dealing with samples of size 4. What happens to this distribution? Well, according to the central limit theorem that we looked at earlier, it says that if you have a normal distribution, so you look at individual batteries, say, and you know the mean, and you know the standard deviation, then you can take samples of any size n, and you can set up a distribution of x bar. And this distribution, we're told, will be normally distributed. We'll have mean mu, and it will have standard deviation. It's given that special name called the standard error. It's going to be sigma divided by the square root of n. So this actually applies to us here because the distribution we're given, we're told, is normal. So it doesn't matter what sample size is, whether it's 2 or 100 or whatever it is. We know that that will lead to a normal distribution. And we know that this distribution will have exactly the same mean as the original, the underlying, 400. And it will have standard deviation equal, the standard deviation of x bar will be 40 over the square root of n, and n is 4. So that's actually going to come to, if we do the calculation, that comes to 20. So the standard deviation of x bar is given the special name, which is the standard error. Whenever you see standard error, it's just saying that we're looking at a sampling distribution, a distribution of x bar. And they want us to find the probability that the average is greater than 440. The average of the 4. And we're looking at averages of 4 here. So we need to find this area over here. So I'll just do it here. I can't just do norm.dist. Norm.dist will just give me the area to the left. XL works to the left. So I have to do 1 minus norm.dist and then we just put in the data, which is going to be the 440. And it's going to be the mean, which is 400. It's going to be the standard deviation, which is 20. And it's going to be 1 or true to find the area in question. We can pop over to Excel now and do that. So let's go over to Excel. So let's do equals 1 minus norm.dist. And we said that the x value is going to be, or x bar value in this case, is going to be 440. The mean is 400. the standard deviation, or standard error as it's called for this type of distribution, is 20 and 1. So remember, the 20 is the 40 divided by the square root of 4. And what does that give us? It gives us about 2%, 2.3, 2.28%. So let's go back. So the answer to this question is, so this area in here, or this probability, is 2.28%. So there's a 2.28% chance that the average lifetime of a 4-pack of batteries is greater than 440 hours. Very similar. If they said what's the probability that a single battery, not the average of a 4-pack, but a single battery lasts more than 440 hours, you would just do it from here. And you'd work out this area here. And this is dealing with a single battery because it's just X. X bar deals with the average of several, or in this case 4. And the equation over here would be very, very similar, but instead of using 20 for the standard deviation as we did over here, we just use 40. The other way they could have asked the question is, what's the probability that the average lifetime of the 4-pack of batteries is less than 440 hours? Well, if they just asked us about less than would have just been working out this, because this would work out the area to the left. And I guess the last way they could have asked us a question is, what's the probability that the average lifetime of these batteries, let's do it here, is between, let's just make up an answer, that's the mean and the standard deviation. But let's do it X bar though. So divide that by the square root of 4. What's the probability that the average lifetime of a 4-pack of batteries is, say, between, I don't know, 380 hours and 415 hours? So again, just to solve this one, it's just you're going to use a norm dot dist of the high figure. So it would just be norm dot dist of 415. Mean is 400. Standard deviation 40 over the square root of 4. Be 20. So that what I've written there is going to give you the area from here going all the way back. It's not going to stop, but I only want the area from here to here, not going all the way back. So I would have to subtract this area in here going back here. So I'm going to subtract from that norm dot dist and I'm going to put 380. So 380 is just this figure in here. 400, 20, 1. And you just pop over to Excel and do that.